In question number 11, it says that the work done by gravitational force on a point mass m0 in moving from the surface of a planet of mass capital M and radius capital R to a height r by 2. So we have to calculate the work done by gravitational force, and we know that gravitational force is a conservative force. So we can write work done by gravitational force will be equal to the negative of the change in potential energy. And since the particle was initially at radius r, that means surface, now it is at height r by 2. So we can write our initial potential energy will be equal to minus of g m m upon r, since it was at the surface. Now what will be the final potential energy? So final potential energy will be equal to minus g m m upon r plus h, and since it is at height r by 2, so if I put the value of height, we will get minus g m m upon r plus r by 2. That will be equal to the minus 2 by 3 g m m by r. So this is our final potential energy. So according to the question, we have to calculate the work done by gravitational force, and that will be equal to the minus of delta U. So we can write work done by gravitational force will be equal to the minus of final potential energy minus initial potential energy. So that will be equal to minus of minus 2 by 3 g m m by r minus initial is minus g m m by r, right? So when you will calculate, you will get minus g m m upon 3r. So we can say that our option number 4 will be the correct choice. Now let's move to the question number 12. In question number 12, it says that a satellite is revolving at a height where it completes its 3 revolutions in one day. If it is shifted to a height where it becomes a geostationary satellite, the ratio of respective distances of orbit from center of Earth is. So we know that the time period of any satellite will be directly proportional to the distance to the power 3 by 2. This is called Kepler's third law. So according to the question, initially the particle completes its 3 revolutions in one day. So we can say that our initial time period will be equal to 1 by 3 day, because in one day it rotates 3 times, so the time period will be 1 by 3 day. And now finally it becomes geostationary satellite. So time period of the geostationary satellite will be equal to the time period of rotation of Earth, and that will be equal to the 1 day. We know that Earth completes one rotation in 1 day, 24 hours, right? So this is our final time period. So we can write the initial time period by final time period will be equal to the initial distance by final distance to the power 3 by 2. So we can write the initial distance upon final distance will be equal to 1 by 3 divided by 1 to the power 2 by 3. So basically we will get 1 by 3 to the power 2 by 3. So we can say that option number 1 will be the correct choice. Now let's move to the question number 13. In question number 13, it says that which one of the following statements is incorrect about the elasticity. So again we have to find the incorrect statement. So first option says there are 3 types of modulus of elasticity. Yes, we know that they are Young's modulus, bulk modulus, and modulus of rigidity or shear modulus. So they are basically 3 modulus of elasticity. So this is a true statement. Second statement says that all elastic moduli have the same unit. Yes, we know that all the elastic modulus will be equal to the stress upon strain. So they will have same unit. So this is also a true statement. Third says that steel is more elastic than rubber. Yes, we know that within elastic limit, steel is more elastic than rubber. It is given in NCERT, right? From the data of the NCERT, we can say that. So this is also a true statement. Fourth statement says that on increasing the temperature, elasticity increases. No, this is a false statement. Why? Because if you increase the temperature, then the volume will expand. If the volume will expand, so the average molecular distance between two molecules will increase. So the force between the molecules will decrease. So elasticity will also decrease. So we can say that our fourth statement is the false one. But we have to find the incorrect statement. So we can say that our option number 4 will be the correct choice. Now let's move to the question number 14. In question number 14, it says that the increase in pressure required to decrease volume by 0.005% of 150 liter liquid in kilopascal is. Bulk modulus of liquid is given. We know that the bulk modulus of any object can be defined as negative of the change in pressure divided by change in volume per unit volume. But according to the question, the volume is decreased by 0.005%. So we can write the change in volume by volume into 100 will be equal to the minus of 0.005%. Why? Because it is decreased. That's why it is negative sign. So we can write our change in volume per unit volume will be equal to minus 0.005 divided by 100, or you can write minus 5 by 10 to the power 5. This is our change in volume per unit volume. And what we need increase in pressure. So that means we have to calculate the delta P, and bulk modulus is given. So if I use the formula, we can write the change in pressure will be equal to the negative of the bulk modulus into change in volume per unit volume. So if I put the values, bulk modulus is given 3 into 10 to the power 9. So 3 into 10 to the power 9 into minus 5 by 10 to the power 5. So how much you will get? You will get 150 into 10 cube Pascal. Or you can write 150 kilopascal. So our option number 1 will be the correct choice. Now let's move to the question number 15. In question number 15, it says that a rod of uniform cross-sectional area 5 mm square weighing 5 kg, length 1 meter is suspended vertically from a fixed support. The elongation produced in the rod is. So basically there is a rod hanging from a rigid surface. So we know that the elongation produced in the rod will be given by the formula mg L upon 2ay, where m is the mass of the rod, L is the total length of the rod, A is the cross-sectional area of the rod, Y is the Young's modulus. So if I put the values here, according to the question, mass is given 5 kg. So we will write 5. G is acceleration due to gravity and it is given 10. So you will use 10. Length is 1 meter. So 1 divided by 2 into area. According to the question, cross-sectional area is 5 millimeter square. So we have to use SI unit. So we can write 5 into 10 to the power minus 6 meter square, and Young's modulus is 2 into 10 to the power 11. So you will use 2 into 10 to the power 11. So this 5 will cancel out. So you will get 10 by 4 into 10 to the power minus 5. So you will get 0.025 into 10 to the power minus 3 meter. So you can write 0.025 millimeter. So my option number 2 will be the correct choice. Now let's move to the question number 16.